Hello everyone, my name is David Retta and I'm a Solutions Architect for the Product and Solutions team at Rafay. I want to welcome you to this video titled The 3 Steps to Migrating from Rancher to Rafay. Before we dive in to do a live demo showing the migration of a Rancher provision cluster, let's briefly cover some of the core strengths of the Rafay platform as well as some of the challenges users of Rancher are facing and how Rafay addresses those with its world-class Kubernetes management platform. Rafay provides a SaaS-based solution that has the deepest integration with Amazon's EKS. Whether you are building EKS clusters with Rafay's Terraform provider or driving EKS cluster lifecycle management through Git operations, Rafay has you covered. Cluster provisioning is only the tip of the iceberg. How do you ensure your clusters have a consistent look and feel and are compliant with global security policies? How do you rapidly deploy updates to critical cluster infrastructure across an organization of hundreds of clusters? Rafay Blueprints with OPA integration allows customers to systematically deploy numerous third-party add-ons and OPA policies across the entire organization. Rafay Blueprints can be auto-updated or rolled out on demand logically across the entire fleet. Utilizing a SaaS approach, Rafay streamlines operations as users are not responsible for the operation and administration of the Kubernetes management platform, saving enterprises hundreds of thousands of dollars on infrastructure and the people to administer and operate it. An entire organization can be audited from a single deployment, and audit logs can be shipped to a number of SIEM platforms, which include Datadog, Splunk, and CloudWatch. Lastly, customers are supported by Rafay personnel who contain a vast amount of experience operating Kubernetes at scale. Rafay solution architects walk customers through the implementation process, and our customer success team ensures the success of our customers. One of the major challenges of hosting Rancher server center around the administration and operation of the infrastructure. Isolation boundaries are addressed with additional Rancher servers. In addition to the increased infrastructure cost, users must also administer the infrastructure and host OS of each Rancher server. Rafay has addressed this with its multi-tenant SaaS-based approach, which removes all infrastructure costs, allowing customers to focus on deploying applications. Clusters provisioned to an enterprise's standard are typically built with corporate policies in mind. Enterprises must ensure only approved applications are deployed, and the clusters deployed throughout the organization do not drift from what has been approved by centralized security organizations. Rafay's cluster templates allow users the flexibility to deploy clusters at will based on a predefined cluster configuration. One of the key components of a cluster configuration is the blueprint associated to the cluster. Blueprints contain key infrastructure components designed to be deployed on every cluster. In addition to the third-party add-ons, Blueprints can manage and deploy groups of OPA policies, as well as enforce drift detection across infrastructure components, reconciling any changes to the blueprint. In addition to access to a world-class Kubernetes management platform, the people of Rafay have extensive knowledge and practical experience operating applications built on top of Kubernetes. Rafay works with customers across all business types ranging from Fortune 100 financial institutions to world-renowned cruise lines. Rafay's Kubernetes experts assist customers with implementation and optimization of Rafay functionality, as well as supporting customers and any issues that arise during the use of the platform. Now let's take a quick look at the steps required to migrate a Rancher provision EKS cluster to Rafay. Step 1 consists of importing the Kubernetes cluster. Import can be done through the UI or fully automated using Rafay's CLI called rctl. Once the imported cluster has been defined in Rafay, a Bootstrap YAML will be generated and downloaded. The Bootstrap YAML can now be applied to the cluster and will deploy the Rafay operator, as well as the selected blueprint. Once the cluster has been imported, it can now be managed by Rafay and used with all Rafay functionality. Step 2 includes the use of Rafay's Zero Trust kubectl access. The ZTKA kubeconfig can be downloaded and used for accessing the newly imported cluster through Rafay. In addition, the newly imported cluster can be accessed and managed via Rafay's CLI, rctl, taking full advantage of Rafay's cluster and application lifecycle management, as well as all other functionality supported by Rafay. Once the newly imported cluster has been fully onboarded, access via Rancher is no longer needed, and all Rancher operators running on the cluster can be removed, and the Rancher server can now be decommissioned. We will now go through a live demo of migrating a Rancher provision cluster to Rafay. We will now start with a live demonstration of migrating our Rancher provision EKS cluster. I've exposed my hosted Rancher server as direct network access is required to interact with managed clusters. By selecting the cluster, we can dive into the specific details of the EKS cluster. By utilizing the kubectl shell, we can see there are 2 nodes and the cluster is running the default components that are installed with all Rancher provision clusters. As mentioned earlier, one of the key features of Rafay is its zero trust kubectl access. This removes the Rancher requirement of direct network access to the Rancher server. We'll download the cluster's kubeconfig, as this will be needed when the time has come to import the cluster into Rafay. Now that the kubeconfig has been downloaded, we can move on to the Rafay console to begin the import process. We will start by creating a new project in the Enterprises org that has been configured on Rafay's SaaS platform. Projects are used as isolation boundaries within the org for BUs to logically separate Rafay resources based on an Enterprise's predefined RBAC policy. We'll select the newly created project and begin the cluster's import process by configuring the environment and type of cluster we will be importing. Clusters can be imported via the UI or via the Rafay CLI, rctl. For the purpose of this webinar, we will use the UI to show the workflows a user will experience while importing a cluster. We'll assign the cluster a name and description to identify the cluster within the Rafay platform. This cluster name can be used as selection criteria for placement policies that are used by Rafay resources such as namespaces and workloads. Let's assign the cluster a location. Locations can be used to logically group clusters as well as selection criteria for an org's fleet operations. For instance, we can assign a workload to a location which will deploy to all clusters assigned to that specific location. We'll then assign a blueprint to the cluster which will deploy the Rafay components required for the cluster to join the org and check into the Rafay platform. To avoid conflicts between the software components already installed on the cluster, we'll deploy a minimal blueprint which will only install the Rafay connector and cluster controller. Now that we have defined the cluster in the Rafay platform and have downloaded the cluster's kubeconfig and bootstrap, we can set up our local terminals environment. We'll start by setting our kubeconfig environmental variable to point to the Rancher provided kubeconfig. This will allow us to interact with the cluster using kubectl and apply the manifest containing the Kubernetes resources necessary for cluster management. We'll check the context to verify the local environment is pointing to the correct cluster. We'll then apply the Rafay generated bootstrap via kubectl to deploy the Kubernetes resources required by Rafay to manage the cluster. On a successful import, you will see that all Kubernetes resources have been created. After a few minutes, the cluster will show up in the Rafay console and we will be able to manage the cluster through the Rafay UI, CLI, and with Rafay's Zero Trust kubectl access. Let's now take a quick look at the cluster attributes. You can see the cluster is an imported EKS cluster and is located in the location we defined during the cluster's import process. The minimal blueprint has been applied to the cluster as well. We can pivot on the cluster to drill down into the cluster configuration. We can view the node configuration as well as the cluster configuration and the additional attributes added by Rafay, such as the cluster labels. We can now access the cluster via the Zero Trust kubectl channel within the web UI. We'll run a few kubectl commands to verify the Rafay components and to exercise Rafay's auditing capabilities. All access to the web UI kubectl channel is captured in the Rafay audit logs. Kubectl commands run through the web UI are captured as well and displayed back to the customer. Let's take a quick look at this feature. From within the console, I'll navigate to the system components and drill down into the audit logs. System, kubectl, and OPA violations are presented back to the customer. Let's select kubectl logs and verify the commands we ran are captured by the system. If using one of the Rafay audit logging forwarding solutions, captured logs can be forwarded to systems such as Datadog, Splunk, and CloudWatch for long-term storage and advanced analysis. A blueprint has been created in a centralized project and shared to the Rancher webinar project. We could drill down into the blueprint and verify the base blueprint version, as well as what add-ons are deployed. For this blueprint, we are deploying the AWS Load Balancer controller, the Secret Store CSI driver, and ASCP, so we can pull secrets from AWS Secrets Manager using IAM roles for service accounts, or otherwise known as URSAs. A custom OPA policy has been created that requires all pod specs have resource requirements and limits set is defined as well. In addition, a drift action to block and notify has been enabled so blueprint components can't be changed by the users of the clusters. Let's go ahead and apply the blueprint to the imported cluster. The blueprint will deploy the add-ons to the cluster as well as some additional Rafay managed add-ons like Rafay's managed monitoring and alerting add-ons built on top of Prometheus and Alert Manager. The defined OPA policies will be applied to the cluster as well, so moving forward, any specs without requests and limits set will not successfully deploy. After a few minutes, the blueprint will successfully deploy and the newly installed components can be used. Once the blueprint has successfully deployed, we can verify the metrics for the different components. Let's start by looking at the cluster metrics. A metric server is deployed to the cluster, which drives metrics for Rafay dashboards. As part of the Rafay managed monitoring add-on, a node exporter will be deployed as well. so you can see node metrics for each node that has joined the cluster. The Rafay Managed Monitoring add-on can also be exposed to drive custom metrics, as well as allowing you to integrate your application's custom metrics to drive things such as HPA. You will also be able to drill down into the specific Kubernetes resources, such as the individual pods, and monitor things such as its CPU utilization, memory utilization, and number of restarts. Now that we have successfully imported our cluster and have feature parity with Rancher, let's grab the cluster's rctl config and kubeconfig. We'll use these to access the system through our terminal, which can help with automating tasks. Let's hop on the terminal. Let's start by adding the kubeconfig to our environment. We'll set the kubeconfig environmental variable to point to the zero trust kubectl config that we downloaded earlier from Rafay. From there, we'll set the current context to point to our imported cluster. Let me run a few kubectl commands to verify everything is working as expected. A really cool thing is happening at that initial command. The Rafay platform is creating a just-in-time service account for cluster access, which will eventually expire. At this point, Rancher and Rafay are coexisting. The Rancher pods are still running in Rancher managed namespaces. We're at a point we can remove Rancher from the cluster if so pleased. With the Rancher provided cluster cleanup manifest, which I will apply to the cluster, a Kubernetes job will be created that will remove all Rancher components from the cluster. If all goes well, you will see the successful creation of other Kubernetes resources. Within about 5 minutes, all Rancher components will be removed from the cluster. After a few minutes, let me run a kubectl get jobs command to verify if the job has been created and completed. As you can see here, the job is completed and took about 2 minutes and 46 seconds. At that point, let me check all the various pods and see which pods are still running on the system. As you can see here, all Rancher pods have been removed. To start taking advantage of automation with Rafay, we will configure and verify the Rafay CLI called rctl. We will use this to drive tasks that require unique workflows. Let me go ahead and start by initializing the environment. We'll point the environment to the CLI config we downloaded earlier. Now that the authentication is in place, we can start running rctl commands to interface with the Rafay SaaS platform. Let me start by grabbing the projects. By default, the environment points to the default project if not set, which is the case with the newly downloaded CLI config. Let me set the default project to the project used for the webinar. I'll do this by running the rctl set project command to the project we created for this webinar called Rancher Webinar. If all is properly configured, I should be able to grab the clusters from the platform. Let me do this by running the rctl get projects command. There is a newly imported cluster that was initially provisioned with Rancher. At this point, you will be able to use all features and functionality supported by Rafay. Wow, that was quick. Within 15 minutes, we managed to migrate our cluster to the Rafay SaaS platform, and we are on our way to saving on infrastructure and administration costs, as well as accelerating delivery of our enterprise's applications, a win for everyone. At this point, we'll conclude the webinar. I want to thank you for your time.